Hey everyone, I just wanted to show you a couple tricks before you start today's lab. So today you are putting batteries or energy sources in series and in parallel. So this is just showing the series right here. So a couple of things I want to show you is voltmeter. How you use a voltmeter is you actually have to place your leads on each side of a voltage change. I'm not sure why I can't grab these. Okay, so each side of the light, there's a change of voltage there. And on each side of the battery, there's also a change of voltage because the electrons are getting charged up. Now, if I switch these, what you'll probably notice is that the voltage becomes negative. It's just showing direction, which way it's going. Okay, same with the light bulb. Now, in real life, if you were to measure current, you would actually have to open up your circuit and you would switch your dial here over to current, okay? Because in real life we buy multimeters, we don't buy specialty voltage in current meters. You could, but you don't. And you'd actually have to hook up your circuit like that to measure current, okay? Now they've done kind of a cheater thing here to make your life easy so that you don't have to always take out wires and open your circuit. It takes a long time. So they made a little cheater method here by just taking this and putting it over the wire. Okay, so that does not happen in real life, but simulators are great because we can make life easy. Now for this lab over here, something you're going to want to do is just turn on this values. Okay, and that way we don't have to continually get a lot of voltage readings. Now please don't change your batteries, okay? Please make sure it's saying 9 volts for your battery. Otherwise we're all going to get different results, okay? So when you come into the circuit here, the voltage at the light, 9 volts, we just took that reading, okay? Current is 0.9 amps, okay? Let's see if it changes on the other side of the, no, it doesn't, it is the same everywhere, okay? So over here, you're going to fill in 0.9 amps. The battery is 9 volts, and the resistance of the light bulb is 10 ohms. Okay? So then what you would do is add in your next battery. And build your circuit back up again. By the way, circuits should always have right angled corners. Okay? So that's why I didn't do this. Alright, so let's see what's happening. So our first battery, 9 volts. Our second battery, 9 volts. Our resistance of our lights stayed at 10 ohms. That can't change. That's just how hard it is for the electrons to get through those wires. But look at our voltage now at our light is up to 18. So it's getting twice the voltage. And if you think about it, it makes sense. So the electron goes through, it gets 9 volts of energy. So it has 9 volts now. Goes through another battery, gets another 9 volts. So now it has a total of 18. It drops off all 18 at the light and comes back at 0. Okay, so we could probably predict that putting a third battery in is going to add another 9, so for a total of 27. And you can build that and check that out. Okay, now for the next sheet, this diagram is exactly the same as the first diagram here. So just copy your work over. And if you don't have a printer, that's fine. Just sketch these out, write in your numbers so that you have them to refer to. There will be some questions on an EDSB assignment later, so make sure you have all this data. All right, so now our batteries are arranged in what we call parallel. Okay, quite a bit different. Probably easiest just to scrap this. Not sure if there's a way to do that. So here we have our next circuit with our batteries in parallel. Please make sure your batteries are pointing in the same direction, because if they are not, what ends up happening is the electrons go around just this circuit and there's no resistance, it gets hot, they catch on fire. So they do have to be pointing the same way. All right, so turn on our values here. Let's see what's happening. Okay, I'm going to pull out here my voltmeter. So measuring on each side of our light, 9 volts. And this makes sense. So electron comes through here, it comes around through the light, drops off its 9 volts, comes back, might go through the other battery this time, and then through the light. So that makes total sense. That is 9 volts. This arrangement makes our batteries last a lot longer. So notice our light bulb's not as bright as when we were putting them in series, one after the other. So when we increase the voltage, the light bulb gets brighter, but it will last a lot longer because really only one battery is being used at a time, so they would last twice as long. Okay, let's see what happens to current. So you're being asked to measure the current in this section, the light, and then also in this section. So notice the current is half in here. And again, that makes sense. These electrons here are alternating, one then the other, one then the other. So twice as many are going by in the same amount of time as in this section. Okay, so think of it, I like to think of it like cars that are merging. All right, so you have one car, let's say every second, one car every second. Now we got to squeeze 2 cars in every second in order to keep the same rate of speed traveling. Okay, so please finish up this lab. Again, make sure you're sketching down your numbers and what would go in these blanks, and then you can go to the ESB assignment and fill those in. All right, have a super day. Miss you guys.